There is a microphone for you.
Okay, so should I use it? Or is it okay? Or should I use it? I should use it, okay. Good evening, everyone. It's not working, right?
Hello, yeah, okay. Once again, good evening, everyone. We are the group number 15, as you can see here. My teammates are Caesar, Johannes, Hossein, and last but not least, the ladies, Joyce, Rainy, and Lita. As you can see it here, we made the logo darker, but our topic here will be discussing about Park and Shop. The question you may have in your mind is, why Park and Shop? What about that? Why not McDonald's? Why not another company? We, on the first meeting we had all together, we wanted to apply in a concrete way all the techniques we learned in this class, in the SixSigma class. And we were thinking very easily with this question, what would we like to improve concerning this quality issue? And Hossein thought about this very common issue that every HKVT student has, which is going to the LG7 Park and Shop at 6:15, just getting some bread and having to wait for more than 20 minutes while he's ready with the octopus card. So that's such a waste of time. So that's why, concerning the question, this is the best illustration that we would like to improve. And the question we'll be trying to answer here is, how can we improve the queuing issue in Park and Shop? So obviously, as every team has done it here, we will go through the DMAIC process. We'll first define the boundaries and the context of our project, to do and to get the efficient measures that we'll be using in the analysis phase. Then this analysis will lead us into getting the good improvement tools that we can suggest to Park and Shop. And finally, we will conclude our presentation by talking about the controlling tools. That will be Hossein again. Okay, so let's move on to the define phase, the first one. We decided to divide our define phase into two parts, the process map first and the cause and effect diagram. We believe that these two tools will let us identify the CTQs, meaning the critical to quality aspects of the project. Okay, so let's move on to the first one, the process map. This is pretty simple maybe to do it, but as soon as we do it, it's very clear for us to identify the CTQ. It's a way to see the whole flowing of the process here in Park and Shop. The first step is very obvious, is when the customer gets inside the Park and Shop store. He will go through the alleys and get the stuff he wants to buy. And the second step here will, in our context, always be about waiting in line, as we will always consider being in this context, wasting so much time in these lines, in these queuing lines. That's such a waste of time. Finally, after these 15-20 minutes, we are in front of the cashier lady, and there are sub-parts within these parts, which is the lady will ask us if we want a bag, yes or no. The second sub-part will be very specific to HKVC. Do we have a student card, yes or no? If we have it, we have a discount, so we better have it. And the third part is actually divided into three branches, is the payment methodology. Should we pay by octopus, by cash, or by credit card? Once we've done all this process, we can just go away, and that's the Park and Shop process map. As you can see it here, it is framed in red so that you can see it more easily, but we've analyzed and we've identified two critical to qualities here, aspects here. One is called cashier scans item, which is actually the number of items that the customer has. The more he has, the more it will get an important influence on the cycle time. The second way, called payment way, is concerning the payment methodology. The time is very different if the customer uses the octopus card or if he uses a credit card. Let's try to see if the second one confirms these two CTQ we've found on the previous one. So we use the fishbone diagram. We can just go through the signification of it very fast. On the right side is the symptom we try to improve. Here is the too long cycle time. These red circles are the possible cause that may infer with the long cycle time, and here we've identified three, either the system, the cashier, or the customer, and all the remaining information will be concerning the subsidiary possible cause. Let me go through maybe one or two. For instance, here it's written typing service number of product for the system. We mean that for some products, either the barcode is not easy to read, or maybe we are going to buy some fruits or some vegetables. There won't be any barcode, so the cashier has to put some manual working on the system, and that's a waste of time. Another example is when the customer doesn't have actually enough money on the credit card or Octopus card, which will delay a lot the cycle time. So yeah, we have a lot to do, so we'll just move on. And again, we've concluded in this second diagram that the CTQ here are the number of items and the payment methodology. So now that we've established precisely the defined phase, we can go on and measure effectively what's Jose's about to do. Yeah.
Thank you, Dennis. Let's move on to the major phase. First of all, what you want to measure? That's an issue. We have two processes here. One is the scan time and one is the payment time. Basically, the scan time depends upon the scan time per unit item. So we have divided the scan times, divide how many persons buys an item. So it's an average number of scan time per unit item. Here is the process capability chart of scan time per unit item. Here you can see that the standard mean and the deviation is quite high as compared what we show in the next slide. And the CPK is negative, minus 0.06. Negative because the mean is shifted after the USL, so it's because that's the negative issue, and the process shifted towards the right hand side. The second part comes to process capability of the payment time. For the process capability of payment time, the sample mean is 15, quite high, and the standard deviation is quite high to show it's 12. Means it is a lot of variation in the process. This is because of three parts. As mentioned, Dennis mentioned that we have an octopus, the credit card, and the cash. So all have different timings. So it's a variation. So the SixSigma box covers all. And again, the CPK is negative. That means the process is unstable, and less than 1, so it's unstable process, incapable process. So up till now, we have identified that due to major phase, both our processes are unstable and are not capable. So what we are going to do is, we are going to break the process capability of payment time into three parts. One is with the octopus, second is the cash, and third is the credit card. In octopus, you can see that the process, the mean is 7 and the standard deviation is 3.6, actually is quite low. And in the octopus, it majorly covers in the lower specification limit and the upper specification limit, but the CPK is again less than 1. But the process mean does not have that much shifted on the right hand side because octopus stays at less than time as compared to credit card, what we assumed till here. The second is the process capability of the payment time by cash. You can see in the cash there's a lot of variation. There's a lot of variation in the cash, and it covers the whole box because it's the reason because the cash people use different amounts. Some give $1,000, some give $500, and they have to give a change, so it uses a lot of time to have a cash. Again, the process capability is minus 0.43, so it means that this process is also not capable. And finally, the credit card. The credit card, both the specification limit, all the points are outside the specification limit. This is the reason because the credit card takes the most time and the least time starts from around 35-38 seconds. So a specification limit according to credit card is not right. And there is a more important point to notice that all have the similar, there's no variation like in the previous ones. There was a variation here, but there's no variation. This is because the credit card is uniform. Like MasterCard or Visa card has the same time process, like 40 seconds or 50 seconds, always take 40 seconds and 50 seconds like that. Now after major phase, we have identified that all processes are incapable. We have divided the process in the cash, octopus, and credit card, and all these processes are incapable. We need to find what's the problem. We need to analyze where the problem lies. For the analyze phase, my friend Cesar will give.
Thanks. And thanks for staying. Well, in the analyze phase, we can see here in this table the frequency or the proportion of the payment method and the number of items for the customers. So you can see that Octopus is around 50%, 40% with cash and 10% with credit card. And also in the number of items, for having a reference, less than 3 items, 56% of people buy less than 3 items. Around 3 and 8 items, 35%, and more than 9 items, 9. So you can have here the whole proportion of the population that is 100. This will be useful because my group mates will describe more about statistics in these two terms. All customer with customer less than 3 items paying with cash and credit card, and an S customer, that it means a customer that buys less than 3 items and paying with Octopus card. So very briefly, the first correlation we're gonna see is the one with scan time and number of items. It's kind of intuitive correlation. You can see that we get all the 100 samples, we graph them, and we can see that the majority of the customers choose less than 4 items, like in the previous table, just for having an intuition for the next steps of our analysis. Obviously, most of the samples are located on the left side, and we didn't decide to cut the graph because we want to have the whole population in this case. Well, one of the purposes of this plot will be to know how much this variable affects the outcome. So here we can see that 67.1% of this variable affects in the scan time. It means that we cannot explain 32% of the variation that could be due to the machine scan error, difficulty in handling the products, and barcode failure. These are opportunities for us to improve the process overall, and hence they will be part of our final suggestions. Lately, we have this other correlation that it's a little bit more complicated to understand because it has 2 different concepts: payment method, payment time, and we can predict with a certain insurance the kind of payment method according to the payment time. So you have here the distribution with credit card, cash, and Octopus, and well, you can see here the confidence interval, and well, this is a model for more probabilistic purposes. So, as a conclusion, 61.6% of the outcome can be explained with the payment method, and the other variation could be just because different credit card payment companies take more time to pay, and well, the change of the cash could be very variable, and well, other processes that we cannot explain. We cannot just. Oh well, that's all for analysis part.
Yeah, hey, ladies and gentlemen, I would like to talk about the improvement phase. And from our previously analyzed and also the measurement phase, we got already the information, or we know that the number of items and also the payment method is quite critical to our cycle time. And therefore we want to continue with our DOE now, and we know already our 2 factors. And our 2 factors are actually first the number of items with 2 levels. One level, the first level is more than 4 items, and the second level is less than 4 items. Our second factor is the payment time, and for payment time we also got 2 factors. The first factor is more than 15 seconds, and the second factor is less than 15 seconds. And I would like to continue with our first chart, the Pareto chart. And you can see on the left side, these are our factors, A, B, and the combination A, B. And on the X bar you can see the effect. And here you can see our 95% level, but also represents our p-value. And here it becomes quite clear that the number of items have the greatest effect actually on our cycle.